Welcome back. This is the day the Lord has made. Let us rejoice and be glad in it. Spend a little time talking about solution concentrations. And so this is for Unit 5 of Chemistry. So some helpful information to start. There's a couple different ways we can express solution concentration, how concentrated is something inside of a solution. The most common way in chemistry is talked about in molarity. Molarity is moles over volume. This is usually used for like chemists that are doing like stoichiometry, because we need to know how many moles you have. So molarity is just how many moles you have in a certain volume. That volume has to be in liters. So if you have a 1 molarity solution, that means there's 1 mole per liter. Also, as you see capital M's, if you see a capital M, it means molarity, often abbreviated as molar. So 1M means 1 molarity NaOH. Another way to talk about concentrations is density. Density is mass over volume. Units can be anything. However, typically for chemistry, it's grams per milliliter. And in physics, we scale it up a little bit to kilograms per meter cubed. You might remember that the density of water is 1 gram per milliliter. Then moles, again, this is a review from a long time ago. Moles is just grams over molar mass. And you can find the mass of the chemical by looking at the individual atoms, mass on the periodic table, and adding them up. These other ones are more for consumers. Mass percent is how many grams you have of it per 100 grams of total stuff. So if you have 1 gram of whatever you want to talk about in 100 grams, that's 1%. And parts per million is similar to mass percent, but instead of per 100 is per million. And we can also use parts per billion or parts per thousand too, depending on how concentrated it is. Generally, parts per million or parts per billion are used to describe things with really tiny concentrations, which might be harmful. Like for example, nitrates are not supposed to be in your drinking water. They measure those things in concentrations of parts per million, and it's up to the water department to make sure that those numbers stay below 10 grams per million grams or 10 parts per million. So a lot of the A-level questions for solution concentrations make you connect these things together and work between them. So sample question, solution of potassium carbonate, K2CO3, has a molarity of 0.015 and a density of 1.05 grams per milliliter. What is the concentration in parts per million? So we're going to take a molarity and a density, those are two things given to us, and we're going to have to turn them into grams per million. What if we standardize this? How many grams would we have in a million grams of solution? So we want this. How many grams of the K2CO3 would we have in a million grams? So we need to know how many grams you have currently and how many total grams you have currently. You'll see that in the question, we're not given that information. We're given a concentration, 2 different concentrations. If you're given a concentration, you want to know the total mass, we can just pick a volume. Generally, it's helpful to pick the volume of 1. If you choose 1 liter, it makes you can find the moles without doing any math. So let's choose a volume of 1 liter. If I choose a volume of 1 liter, I can find the mass of solution because density is mass over volume. So density is grams per milliliter. We chose 1 liter. 1 liter is 1,000 milliliters. And so we're going to be solving for the grams here. 1.05 grams is per milliliter is my density. We're looking for grams. My volume is 1,000. That means our mass of the solution is 1,050. And we could have chosen any volume I wanted. I chose 1 liter arbitrarily. Then we can find how many grams that we have, because now we have a volume. And if we have a volume and a molarity, we can find moles. So our molarity given to us is 0.015. We chose a volume of 1. And since we chose volume 1, the molarity is the moles. So if we had a 1 liter solution with this molarity, that's also the moles. Now we can turn that moles into grams. Grams just equals moles times molar mass. So here's the moles we have. Here's the molar mass of K2CO3. That's how many grams you have. So we go back to our expression here and put the numbers in. We have 2.07 grams potassium carbonate, 1,050 grams of solution. And we could have chosen a different volume. We would have found the same proportion. It's about 2 to 1,000. So now we proportions up to parts per million. Well, what if we had a million grams of solution? And so we cross multiply, solve for X, it turns to be 1971. What if the question had, instead of asking for parts per million, just wanted to have a mass percent? The only thing different is, instead of proportion to a million, we proportion to per 100. So all that happens is, instead of putting a million on the bottom, we put 100 on the bottom. And so cross multiply again, and that is the percent by mass. So big idea, there's a whole bunch of ways to talk about equations. We talk about solution concentrations. If you want to find parts per million or parts per 100 given molarity, and density, choose a volume. You don't need to pick 1 liter, but I'd recommend picking 1 liter. Have a great day.